limit of function in two variables. Let's begin by remembering the limit of function in one variable. Let's suppose that we have a function y equal jx. Remember that the limit of the function jx at a uh, exists if the limit from right equal limit from left equal a real number, L. In this case, this real number L will be the limit of my function jx when x approaches a. Here in the sketching, the point x approach a from right. So when x approach a from right, the number here, this is L. If L equals GA, so the function will be continuous at A. But in general, it could be L different from GA. So we have, when X approaches A, so X moves on the line X axis. So X could approach from right and X also could approach from left. Like this, X approach A from left. Now, for a point in the plane, if we have a point in the plane, AB, and if we have a point XY, if XY approach AB, so it could approach not only from right and left, so it could approach in any direction. So this is the difference between function in one variable, like this function jx, and the function fxy in two variables. So to understand this, let's take this example. Let's take the function fxy equal y over x, and let's search the limit of fxy when xy approaches 0, 0. So let's first take the line L1, y equal x. So let's suppose that we have a point here, it's xx, and this point approach the origin 0, 0. And let's calculate the limit of fxy when xy, the limit of fxy here, when xy approaches 0, 0, but on the line L1. So if xy moves on the line L1, given by y equal x, the limit of the function will be limit of x over x when x approaches 0. So the answer is 1. But when the point xy moves on the line L2 with the equation y equal 2x, so this is the line L2 in red, sketched here. So if I suppose that I have a point here, this point x2x, and this point approaches 0, 0. So what is the limit of the function in this case? So here I have a point m x2x approach the point O 0, 0. So when the point M approach O, let's see the point FM, the number FM will approach what? It will approach 2. So on the line L2, F of the point x2x will be the limit of y over x will be limit of 2x over x equal 2. So this is on L2, but on L1, Fm, if I suppose this point now, M, let's call it M1. What is Fm1? Fm1 will approach 1. So the limit of the function fx, now, this limit, in the direction L1 is different than the limit of the direction L2. So for this reason, the limit of y over x when xy approaches 0, 0 doesn't exist. Okay, let's take the general definition of the limit of a function in two variables. If for any function jx jx such that the limit of jx when x approaches a equal b, because I will suppose that the point here ab, okay? If we have for any function jx like this, we have the limit of xjx. Now instead of y, I will take jx. If the limit of fxjx, now fxjx, it's a function in one variable x. So I can take the limit of this when x approach a. And now I know what is the meaning of this limit, because it's a limit of a function in one variable. So if this limit is equal to a real number L, and this real number is a constant, doesn't depend on the function g. So if I change g, this number L will not change. So if this limit of f xjx when x approaches a equals to a constant real number L, different from infinity also, then the limit of the function fxy when xy approaches a will be also, by definition, this real number L. Okay, this means if I choose at first g1, satisfying this condition, like this one in blue, function g1, and if I suppose that the point here, xy, approach the point AB on this direction, okay, on the graph of the function g1, if the limit of fxy will be L for g1, and also if I choose any another function j2 and I take any point here xy approach on j2 approach AB, also the limit of f x j2x will be also L. In this case, the limit of fxy will be this real number L, because in any direction, if I choose any direction, the limit of fxy will be always L. So this means xy approach AB in any direction. Now here, this approach in any direction, not only from right and left. Okay. So let's take this important remark that if we can find two functions, j1x and j2x, satisfy this condition that the limit of jx when x approach a equal b, and the limit of fx j1x here is a real number L1, different from this limit, a real number L2. In this case, this limit of my function f doesn't exist. Okay, so this limit doesn't exist because the limit in the direction g1 is different than the limit in the direction of the graph g2. Okay, let's take some examples. Evaluate the following limits. Evaluate means search if the answer exists, is it a number or it doesn't exist, etc. So here we have x power 2 plus y power 2 over x times y. So let's choose at first any graph passing by the origin 0, 0. So let's take y equal 2x, for example, and y equal 3x. These are two graphs, okay, passing by the origin 0, 0. So if I choose y equal to x, so what is the limit of my function? Let's suppose that this function here, fxy, okay, and xy approaches 0, 0. So let's take the limit of fx to x when x approaches 0 now, only x. What is fx to x? I will put instead of y 2x, so 2x power 2 over x times 2x when x approaches 0. So up it will be 5x power 2 and down 2x power 2, and I have limit when x approaches 0. So it's the limit of 5 over 2, so it's 5 over 2. Now let's take y equal 3x. So it will be the limit of fx 3x when x approaches 0 is equal to the limit of x power 2 plus 3x power 2 over x times 3x when x approaches 0. So 9 plus 1, it's 10, the limit of 10x power 2 over 3x power 2 when x approaches 0. So it's 10 over 3. Now, because these two numbers are different, because they are different, so the limit doesn't exist. So the limit of x power 2 plus y power 2 over xy when xy approaches 0, 0 doesn't exist. Next exercise. So here, if we put instead of x1 and y1, so it will be 1 minus 2 plus 1 over 1 minus 1, so it's 0 over 0. Okay? So the term up would be written as x minus y power 2, and down x minus y when xy approaches 1, 1. So this is the limit. We can delete now, so it's x minus y when xy approaches 1, 1. When we write here xy approaches 1, 1, so xy closed to 1, 1, but not equal to 1, 1. So x is not equal to 1, y is not equal to 1, but so close to 1, 1. So I can cancel here these two terms. I can cancel this term with this term because x is not equal to y, because they are close to 1, 1, but they are not 1, 1. Okay. So after that, let's write now instead of x1 minus y1, so it's 0. So the limit is 0. In this exercise, we have sine x power 2 times y over y. So let's write this is equal to the limit of sine x power 2 times y divided by x power 2 times y times x power 2 when xy approaches 0, 0. Now here, let's suppose x power 2 times y equal a new variable t. Okay, so I have two limits. Limit of x power 2 when xy approaches 0, 0 times the limit of sine t over t. When xy approaches 0, 0, then t approaches 0. So this limit is 1 times this limit is 0. So the final answer is 0. Next exercise. Limit x power 2 y power 2 times e power x power 2 y power 2. Let's suppose x power 2 y power 2 is a new variable t. T is positive or 0. Okay. So the limit will be the limit of t times e power 1 over t when t approaches 0. So if we put here t approaches 0 positive because t greater or equal 0. So if we write 0 times e power plus infinity, so e power infinity, so 0 times infinity doesn't exist in determinated form. So let's go back to this limit here, limit of, let's write this as e power 1 over t divided by 1 over t where t approaches 0 positive. So let's suppose here 1 over t, a new variable z, for example. So it's the limit of e power z over z when z approaches plus infinity, because when t approaches 0, 1 over t approach 1 over 0 positive. It's infinity. So here it's infinity over infinity. Now we can use the L'Hopital rule. So it's the limit of derivative of e power z, it's e power z, derivative of z1 when z approaches infinity. So the final answer is infinity. Next exercise, and this is the last exercise. The limit of x power 2 times sine y power 2 minus y over x3 minus plus x. So here, this term sine y2 minus y over x3 plus x. This term always between minus 1 and 1. So let's product by x power 2. So minus x power 2 is or equal x power 2 times sine y2 minus y over x3 plus x less or equal x power 2. Now, when xy approaches 0, 1, okay, if I put 0, 1 here in this term, I will have 0 over 0. Okay, so now when xy approaches 0, 1, so x approaches 0. So this approach 0 when xy approaches 0, 1, and this is also approaches 0 when xy approaches 0, 1. Okay, now by squeeze theorem, so the limit of x power 2 sine y2 minus y over x3 plus x will be also 0 when xy approaches 0, 1.